Hi everyone, welcome back to a new video. Today we are going to solve a new question from top interview 150 of Leetcode, and the question name is trapping rainwater. This is a hard level question. Although if you have solved the candy problem that we had discussed in the previous video, this question will be quite easy for you to solve because the approach that we will be following in trapping rainwater will be quite similar to the candy problem. And if you haven't checked out the video, I would recommend you to check it out. You don't have to watch the entire video, just check out the brute force approach, so you will be able to implement the trapping rainwater in the same way. So now let's move on to the problem description. So now let's see the problem. Now in this question we have been given n non-negative integers, and those integers represent an elevation map. Okay, now what is this elevation map? So let's say we have a graph which is representing the height or the height or elevation of the ground. Okay, so if we have been given 1 in the graph or the array, then it means that the height or the elevation of that ground will be 1. Okay, and we will be representing 1 like this, and let's say we have another value which is 2. Okay, so we will be joining the graph or the bar with means with the previous one, and we will continue like that. Okay, there will be no gaps between the elevation. Why are we doing so? We are doing so, the gaps or the difference between the height of the elevation can store water. Okay, so now let's say if we have a height like this, okay, or the elevation is given like this, means the first one is 0. After this we are given 1, 2, 1, 1 and 2. Okay, so now what do we need to do here is we need to return the amount of water that can be stored or trapped inside this elevation gaps. Okay, so now this is 0, right? So if we are trying to trap water here, it will flow from there, so we cannot trap here. Here also it is not possible. Now here in the with the height of 2, we are getting an elevation, but we need to, how do we trap water? It will be like between two high walls and a depth, right? So here we can see a depth is being created, right? So whatever water can be stored will be, or whatever water can be trapped there will be trapped here only. So we will have 1 unit of water and 1 unit of water here, so total 2 unit of water can be stored here. So now let's see one more example. So here what we have been given the example as 0 1, and in the same way 0 1 2 1 whatever. Let's move on. So here the height is 0, then we have 1. Now this is 0, this is 1 again. When we have 0, so this whatever space is left between, the height here was 2 and the height here was 1, so there is a difference between both of them, right? A gap is created, and with we need to fill that gap only. Okay, so it will be filled with 1 unit of water. Now we have maximum height till now as 1, 2, right? So when we will move forward, we see that we have 1 unit elevation. So if we have 1 unit of elevation, and since like we have a wall, one more wall here which is of high elevation, that means that we will be able to trap water here, right? So whatever water will be trapped here will be of height 2, because we are moving from this end, right? So if we are trapping water here, it will be of height 1. In the same way it will be of height 2, because the gap here was for 2 unit of height, right? And here we have 1 unit elevation, so 1 unit water will be stored. Now the question is, here we have a height of 3, then why are we not storing 1 more unit of water here, right? Now when we will see that, if we are trying to store 3 unit of water here, what will happen? We don't have a wall here, right? So the water will be flowing from the other side, and in order to store anything or a liquid, we need walls from both the sides which will be storing the water or trapping the water in between, right? So since we cannot trap the water here, therefore we will not take the height of 3. Okay, so now we have an idea that although we will be taking the maximum height, or the we will be comparing and trying to get the maximum height, but we need to check for walls, that can we form walls which will be able to trap water or not, right? So in the same way, after 3 we move forward and see that we have 2 here, then we have 1, and again we have 2. So in the similar way we are getting a wall here which can trap 1 unit of water. So it will be trapping 1 unit of water, and we will move forward, and we have 1 here. Since we do not have any other wall here, so we will not be able to store any water here, and we will be getting only 1, and here will be 4 unit of water, and here we will be getting 1 unit of water. So total we will be storing 6 unit of water between the walls. Now the question comes, how do we approach the problem, right? How do we try to solve this problem, and how are we coming to know that how much amount of water we need to store, right? So we'll start from here. We will be moving from left to right. Okay, so we will observe one pattern that, let's say we have 0 here, okay, and we have 1 here. Now since this 0 is like the we have 0, before that we don't have any wall, so we will not be able to store any water here. So we will move forward. Now we have 1 here, okay, and we have 0 here, and we are seeing that if we have 0 and we have 1, and here also we have 0, so we are getting a kind of wall here, right? And this wall that we are having, the water stored is equals to the amount, like the height of the wall here, right? Means if we have a wall like this, now this whatever amount of water will be stored, it will be of the height of the same wall, right? Now let's say if we have a wall such as 2 unit height and 1 unit height, then also we will have 1 unit of water only, because if we try to trap 2 unit of water, it will overflow from this side, right? So we need to take care that although we have to take the maximum height, we need to check for the overflow condition, right? So here when we are moving from left to right, let's consider this situation only right now. So we saw that we have 1 here and 0 here, so we are able to trap 1 unit of water. So we have an idea that something of maximum will be involved here, because when we will move forward, we see that we have 2 here, okay, the height of the wall is 2, and here it is 1. So when we will be comparing this 2 and 1, then the difference between this 2 and 1, that amount of water is being stored here, right? Means 2 minus 1, 1 unit of water is stored here, right? And now when we are moving forward, we see that we have 0 here, and when we are doing 2 minus 0, we are getting 2 unit of water in the same way. So we are trying to take the maximum height, and we are storing the difference of that maximum at that position, right? We are subtracting maximum value with height at that position, right? So again if we see that we have 2 here and 1 unit of water is here, then we can see that we are getting 2 minus 1, again we are getting 1 unit of water here, right? So when we are moving from left to right, we are observing a pattern that we are taking the high value, right, the maximum value, and we are subtracting it with that at the height at ith index, right? Now at like currently we have maximum as 2, right? Before we on the like on the beginning, or in the beginning, we had 1 as the maximum, and then we move forward, we got 2. Till now we have 2 only, but when we move forward we have 3 here, right? So what we will do here, we will be getting 3 right now. Since we are moving only in one position, so according to this, if we are we have 3 as maximum, so if we try to get the difference, so we will be getting 1 unit of water here also. So let's take into the consideration that we have 1 unit of water there, because right now we are moving from left to right, so we don't know if on the right side we have a wall or not, right? So we are taking 3 minus 2 1, so we are getting 1 unit of water, right? Now we are on this position, we will be moving forward. Again what happens, we have 1, right? Now this 3, what we will do, we will do 1, right? 3 minus 1, and we will get 2 unit of water. Why? Because till now maximum value is 3 only, okay? So according to this, we will be storing 2 unit of water, right? So we have, since we are moving from left to right, there is a chance that maybe we will have a 3 matlab a wall of 3 here, a wall of 3 elevation here. So uh, till now we have 2 unit of water according to maximum as 3. So we will move forward again, we will have 2 here, so we will again get 1 unit of water according to the left to right condition. So we have 3 minus 2, 1 unit. And now on the last index we have 1. So according to the position that we have been given here, we will be getting 2 units of water here. Okay, so we have 2 unit of water here. Now what we need to do here is, since we are having whatever difference we are taking, let's store it in an array. Okay, so we will have a count of whatever amount, how much amount of water can be stored there, right? So we will be starting from this position. Okay, right now we have maximum as 0, and what we will do, we will move here, and what will happen, maximum will become as 1, right? So what we will do, we will store maximum here. Right now we will not store the difference, we will only store the maximum values. Okay, so here when we will move forward here, we will see that the previous value that we have, let's take a maxi value, and we will be storing the values there only. So this previous value that we have stored, it will be staying the same, and now we have 0 here, right, on the second index. Now we will compare this maxi and 0, so 1 will be stored again. Now we will move to third index, we will compare 2 and 1. So now our maxi will get updated to 2, and we will be storing 2 here. Again we will be moving forward, and we will have 1 here. So it will not get updated because 2 is greater than 1, so it will be staying as 2 only. Now we will move forward, we see that we have 0 here, so again it will be staying as 2. In the same way we will have 2. Now we will be comparing 2 and 3, right? So 3 is greater than 2, therefore 3 will get our maxi will get updated, and we will be storing 3 here. Fine, we have 3. Now we will be comparing this 3 with 2. Again 3 will be stored here. Let's erase this. Now we have 1 here. Okay, so again we will get 3 here. In the same way we will get 3 again and 3 again, right? Because after this 3 we are not getting any value that is higher than that, right? So right now we have an array. Okay, this is array 1. We are storing the maxi from left to right. Now we see that while we were storing the values, we were not able to predict the wall when we were moving from left to right, right? We were like, we took 3 here, okay, and we continued according to that only, because we got here 1 unit and 2 unit, right? But we should get only 1 unit of water here, because we were not able to form a wall here, right? And in order to avoid that problem, right, we need to have an idea what will happen, are we getting any wall from right to left, that then only we will come to know if there is a wall or not, right? So what we will do, we will start moving from right to left now. Okay, so that we can predict if we have a wall or not, and then we will choose the values according to that, or we will get the amount of trapped water. Okay, so now what we will do, we will start from here, and we will compare these both values. Fine. Now let's say we have an array, let's name is array 2. Okay, now the length of the array will remain same, we will be starting from right to left. Now the last position will be same, so it will be 1. Now we will be comparing this 1 and 2. So what we will get as maximum till now, now we will get 2 here. So we have maxi 2 here, and now the value of maximum is 2. Again what we will do, now when we are moving from right to left, we see that here from left to right when we were moving, we got here 2 units of water, right? And we were supposed to get only 1 unit of water. Now when we are moving in the opposite direction, we see that if we are taking this 2 as maximum, so what we will get, 2 minus 1, therefore we will be getting only 1 unit of water. So what we are doing here, if we are having two values at a position, we need to get the kind of minimum out of that, right? What I mean here is, I was storing the value from here according to 3, okay? But this 3 unit of water that I added was extra because I don't have any wall here. And we need to take the value that is, although not greater than that, not, we don't have any value greater than 3, we need to get the value that is nearest to the small value to 3, okay? So here the nearest value is 2. Therefore what we will be doing here is, we will be storing the value from the back, from the reverse direction, and we will try to get the minimum value according to the 3 here. So now we have 2 here and we have 1 here. So if we take the value in reverse direction, then we will be getting a right answer. So till now we will be storing here 2, right? Because in this 1 and 2, 2 is maximum. Here we have 2 only, so we will be storing 2 here. Now again we will come across 3, so we will take this 3. Now we will compare with all these values. Then what will happen, we will be getting only 3 here, right? Because in the entire array that is left, 3 is the highest, so it will be getting updated to 3 only, right? So what we will do here, we will take, this will become 3, this will also become 3, this will also become 3. All the elements that are left in the array on the left end will become 3. Now when we were moving from here to here, like the highest value we will leave it. Now when we were moving from this end to this end, the value that we were getting on subtracting with the maximum value was right? Means when we were subtracting this highest value from 0, then we were getting 1 unit only. When we were subtracting this 1 from 2, we were getting 1 unit only. Therefore what we are seeing here, that here this part, now here after 1 3, since there is no bigger value, everything got updated to 3. But we cannot take that 3 here, because every value will be formed with like the water will be trapped between a wall and the second highest value was 2 here, right? We don't have an elevation of 3, so we cannot store the value according to that. Therefore what we will do here, we will consider the minimum of both of these value, okay? So when we will be storing water, or when we will be finding the difference, we will be taking the minimum value of that. Why do we do that? Because if we are seeing the pattern here, okay, so now if we are considering 0 here, okay, so here we cannot store any water, so water stored here will be 0. Now here what we have 1, right? So what we need to do here is, we need to subtract the height of I. Why am I subtracting height of I, we will come to know. Now this is the maximum value here, right? This is not the array that we had stored, this is the comparison value that we found out when we were comparing the height with each other. So this height, whatever array at first index we have, we are subtracting from height of I. So again 1 minus 1, we will get 0, since we cannot store any value here, right? Again the minimum of 1 and 3, what we are getting 1, right? Now we have height of I at this index is 0. So what, like how much amount of water we are getting, we are getting 1 unit of water. Again what we are doing, height of I at this index is 2, and arr of I is also 2, so we will get 0 here. Now when we move forward, we have 1 here, we have 2 here, so again it will get updated to 1. Now in the same way we have 0 here, so we will get 2 minus 0 as 2, and here we have 1 and here we have 2, so we will get 2 minus 1 as 1, right? Now what do we have here, we have 3 here, right? So what we are doing, we got a new maximum value, but since it is the highest value, we cannot store on any water or any amount of water over that, right? So we will simply reduce that and it will become 0. Now if we take this entire 3, okay, so according to that we will be getting 1 unit of water, which is not possible because we don't have any elevation after that, or any upcoming elevation which is greater than 3 or equals to 3, right? So we cannot store any amount of water according to 3 there. Okay, so we need to go and check in the minimum now. Okay, so when we compare both of these value, what minimum we are getting 2 as minimum, right? So this 2 and the height of that in height at that index is also 2, so we will be getting 0 here. Now we have 1 here, and the minimum value at that index is 2, so 2 minus 1 we will get 1 here. Again 2 minus 2 we will get 0, and here 1 minus 1 we will get as 0. So when we will sum it up, how much we are going to get? 1 plus 1 2, 2 plus 2 4, 4 plus 1 5, 5 plus 1 6, and this was our expected output, right? So what did we do here? We simply moved from left to right and we checked for the maximum value. Okay, when we found out the maximum value, okay, and we found, after that we moved from right to left so that we can come across the positions or the condition where we can form a wall. And if the wall if the wall is formed, then only we can trap water. So we are finding the minimum value out of that, because the basic approach for this is, if you have a wall or if you have a value such as we have been given 3 here, if we consider 3 and we find the difference according to that, or the we trap try to trap water according to that, we need to have another elevation which is of height 3 or more than that, then only we will be able to trap water inside the walls, right? Since we don't have any value which is greater than 3 or equals to 3, so we will be moving from right to left again, right? And we will be finding the value, or we will be trying to find the highest wall from the opposite end. Now what is happening? We got the required value in both the arrays, right? And after that what we are doing, although we have a maximum value as 3, right, moving from this end, right, this entire value we had 3, but we cannot use that. Why can we not use it? Because the water will not be trapped in according to the highest value. We are using that in order to get the required answer, or the or we are trying to find the next highest wall in this area, right? Let's say if the at 0th index we had 4, okay, then this would have come in use, right? Here we had stored 4. If we had stored 4 here, okay, so here we would have got 4, and then we would have stored water according to the different value, right? So we need to keep account of the walls, or we need to get the highest wall that can be formed in order to trap the water, and then we will move forward. We will find the minimum of both of them at each index, and then we will subtract at that index, okay? And after that what we need to do here, we need to find the total amount of the water, or the total amount of water that can be trapped between the walls, and we need to return it, okay? So now let's move on to the code editor, and we will try to run this code there. So let's see the code now. We will be following each and every step that we saw in the approach, okay? So as we started from left to right, we will be following that in the question, in the code, and in the same way we will be going from right to left also. And before that, let's uh, declare all the required variables. We will be requiring 2 arrays, okay? So we will declare those. We will be initializing them with 0, and the length will be n. N is the length of height here, so let's take the length. Now we have arr1, we have one array. Now first let's fill that array, okay? So we will be going from I in range of n, right? Now when we are doing the comparison, in the in the approach we discussed that we can take a maxi, right? So we will be declaring one variable for that. Instead of that, what we can do, we can take the previous value in the array and we can compare with that, right? Let's say if we have 0 in the array, okay, in the array which has the maximum value, and right now at 0 we are on the first index, right? So this, if we are comparing this 0 and 1, we will be getting 1 only, right? After that, if we are comparing this 1 with 0 again, we will get 1 again, right? If let's move on and see if we are getting the same values as required or not. So now what we will do, we will compare this 2 with 1. So what we will get again, we will get 2 only, right? So maximum also was storing the previous maximum value and it was comparing it with the current value, right? In the same way, we are comparing the values here and we are getting the maximum here also in the same way. So instead of using the maxi variable, what we will do, we will simply compare the value with the current value with previous value. Now what we are doing here, if we are trying to compare the current value with previous value, if we will start from 0th index, we will get index out of range error, because if we are at 0th index and we try to compare it with 0 minus 1, that is minus 1th index, it will not exist, right? So for that, what we will do, we will start from 1 index. Now the array that is storing the maximum value, it need the 0th index needs to be initialized, right? So for that, what we will do, at 0th index we will initialize it with the height at 0 only. So it will have height at 0. Now we will compare the values, right? And we will store at the current index. So ARR of I will be equals to max of ARR of I minus 1 and height at that index, right? This will also be ARR of 1, right? So now we have an array from left to right which will be storing the maximum values. In the same way, we will have one more array which will be storing maximum values from right to left. So let's take one more array and it will be storing from right to left. And let's start iteration. Here what we will do, we will be comparing n minus 2 value with the n minus 1 value, right? Means if we have 2 here, we will be comparing it with 1, right? Now if we start the value or the iteration from the last index, what will happen, if we are comparing I with I plus 1, we will get index out of range, right? What I am trying to say here is, if I am starting from n minus 2 and I am trying to compare with n minus 1, then it is possible. But if I am trying from starting from n minus 1 only, then I will get an error. So since I am comparing with I plus 1 value, for that I am starting from n minus 2 and we will go to 0th index, right? And since our ARR2 is initialized with 0, we need a value on the last index. So for that, what we will do, we will initialize the last index value. Let's do that. So we will initialize it with height at I naught. It will also be n minus 1. Now what we will do here, we will store the maximum values in the second array. Max of ARR of I plus 1 and height at I. After this, what we were doing, we were taking the minimum of both of that value and subtracting with the height at I, right? Now what we can do here also, we can take we can take a new array and we can store the entire value in that array. Means we can find the different minimum and we can get the difference and store at that index, or we can use any one of these array also, and in that also we can perform the operation. So let's take ARR1 only, and in that only we will perform the operation. So we will move from 0 to n and n minus 1, and for that what we will do, we will take the minimum, right? So ARR1 of I will be storing minimum of ARR1 of I comma ARR2 of I. Why are we taking the minimum value? Because this minimum value will be the amount of water that we will be able to store, right? Means if we are taking in the approach, we saw that we got 3 values, 3 as the value when we were moving from right to left here, right? These all became 3, and when we were moving from right to left, the entire part after this here became 3, right? So in order to avoid the highest value, and in order to get the amount of trapped water, we will take the minimum of the both the values, right? And since the trapped water will be the difference between the value at that index and the minimum value, so we will take the difference and store it. So now what we are doing, we are iterating and we are storing the minimum of both values and subtracting it with the height at I, and we are now storing all the values in the ARR1 only. After this, what we need to do, we have the values that need to be stored, right? After this, we need to return the sum. So what we will do, we will simply take the sum of ARR1 and we will return it. So now let's try to run it. Okay, here we will have ARR of 2. Let's try to run it again. So the sample test cases are passed. Let's try to submit it. So this code has been accepted. That's it for today, guys. Thank you for watching. I hope I was able to help you out with this question. If I did, please let me know in the comments. And in case you have any doubts, let me know in the comments too, so that I can clarify it even more and make it easy for you. And in order to continue with me in this coding journey, please subscribe to my channel and hit the bell notification so you will be notified every time I post a new video. Thank you for watching.